हेलो स्टूडेंट्स। कल हमने खत्म किया था कंसेप्ट्स अबाउट इनवर्स ट्रिग्नोमेट्री। सारे फॉर्मूलाज और प्रॉपर्टीज हमने कर ली थी इनवर्स ट्रिग्नोमेट्री की। आज कुछ क्वेश्चंस करेंगे हम इनवर्स ट्रिग्नोमेट्री के ऊपर और चैप्टर को सम अप करेंगे। तो फर्स्ट ऑफ ऑल क्वेश्चन सेज फाइंड द वैल्यू ऑफ tan of 2 tan inverse 1 upon 5. Tan of 2 tan inverse 1 upon 5. अब tan of 2 tan inverse 1 upon 5, इस क्वेश्चन को दो तरीके से कर सकते हैं। कैसे? पहला, we know the formula 2 tan inverse x is equal to tan inverse 2x upon 1 minus x square. 2 tan inverse x is tan inverse 2x upon 1 minus x square. Using this formula, this is tan of 2 tan inverse x, that is tan inverse 2x, 2 into 1 upon 5 divided by 1 minus x square, 1 upon 5 the whole square. So this is tan of tan inverse 2 upon 5 divided by, this is 1 upon 25, 25 minus 1, 24 upon 25, LCM ले लिया, और this is tan of tan inverse 2 upon 5 into 25 by 24. So this is 5 5s are 25, 2 12s are. So tan of tan inverse 5 by 12. So your answer is 5 by 12. So this is one way of solving the question. Now same question, how it can be solved in other way around? Just check it out. Same question, tan of 2 times tan inverse 1 upon 5. Now this tan inverse 5, let this be theta. So tan 2 theta or tan 2a, formula is 2 tan theta. Let tan inverse 1 upon 5 is equal to theta. This implies tan theta is equal to 1 upon 5. Now this tan 2 theta is 2 tan theta upon 1 minus tan square theta. It is 2 into 1 upon 5 upon 1 minus 1 upon 5 square. This is 2 upon 5 into 25 by 12. Again comes out to be 5 by 25 by 24. 5 by 12. So your answer is 5 by 12. So you can do it either way around. Another question. Find the value of cot of tan inverse A plus cot inverse A. Tan inverse A plus cot inverse A. Now we have done a property yesterday that says tan inverse x plus cot inverse x is equal to pi by 2. So quite simple, tan inverse A plus cot inverse A is pi by 2. So this is cot of pi by 2. Now cot pi by 2 is 0. So your answer is 0. Another question. Sine of pi by 3 minus sine inverse minus 1 by 2. Now sine inverse minus x, we have a formula sine inverse minus x, sine family minus sine inverse x. So sine inverse minus x is equal to minus of sine inverse x. Using this, sine of pi by 3 minus plus sine of half. Now sine half कब होता है? Sine inverse half, sorry, sine inverse half. तो sine half कब होता है? 60 डिग्री पे. तो sine inverse half is pi by, sine inverse half is pi by 3, sorry 30 डिग्री पे होता है. Sine inverse half कितना हो गया? Is equal to pi by 6. So pi by 3 plus pi by 6. Is it sine of pi by 2 is equal to 1. Another question. Prove that tan of half sine inverse sine inverse 3 upon 4 is equal to 4 minus root 7 upon 3. Now to prove this thing, let half sine inverse 3 by 4 is equal to theta. So sine inverse 3 by 4 is 2 theta. So sine 2 theta is 3 by 4. Now if sine 2 theta is 3 by 4, what about cos 2 theta? It is under root 1 minus sine square 2 theta. It is under root 1 minus 9 upon 16, comes out to be under root 7 upon 4. So value of cos 2 theta is under root 7 upon 4. Now left hand side, it is tan theta. Could be written as sine theta upon cos theta, or this could be written as 2 sine theta. Sine square theta upon 2 sine theta cos theta. What we have done? Multiply and divide by 2 sine theta. So 2 sine square is 1 minus cos 2a upon 2 sine a cos a is sine 2a. 1 minus cos 2 theta, that comes out to be 1 minus root 7 upon 4. Sine 2 theta is 3 upon 4. So taking LCM, 4 minus root 7 upon 3. So that's all. This is your right hand side. Hence proved. Easy. Then another question. Prove that tan inverse 2x under root 1 minus x square upon 1 minus 2x square is equal to 2 sine inverse x is equal to 2 sine inverse x. Proof. Put x is equal to sine theta. So theta is equal to sine inverse x. Using that, left hand side लो, tan inverse x की जगह पे sin theta पुट करो, 2 sin theta into under root 1 minus sin square theta upon 1 minus 2 sin square theta. Now this is tan inverse 2 sin theta into cos theta upon 1 minus 2 sin square theta. 1 minus sin square is cos theta and 1 minus 2 sin square theta, that is cos 2 theta. Cos 2 theta. 1 minus 2 sin square theta is cos 2 theta. That is tan inverse sin 2 theta upon cos 2 theta. It is tan inverse tan 2 theta. This is 2 theta. It is 2. Theta is sin inverse x, which is your right hand side. So quite simple. Why we have substituted x is equal to sin theta? Because we have under root of 1 minus x square, and we know the substitution for a square minus x square. Put x is equal to a sin theta. Now a in this case is 1. Here a is equal to 1, so x is equal to sin theta. Fine. Another question. Prove that tan inverse root x, tan inverse root x is equal to half of cos inverse 1 minus x upon 1 plus x. So let put root x is equal to tan theta. So theta is equal to tan inverse root x. Take right hand side in this case. Half of cos inverse 1 minus x upon 1 plus x could be written as half of cos inverse 1 minus x can be written as root x the whole square upon 1 plus root x the whole square. This is half of cos inverse 1 minus tan square theta upon 1 plus tan square theta. Now हमने प्लस वन में पढ़ा है 1 minus tan square upon 1 plus tan square किसके बराबर होता है cos 2 theta. Half of cos inverse cos 2 theta. So half of cos inverse cos 2 theta is 2 theta is equal to theta, which is tan inverse root x is equal to left hand side. Is that okay? So another question. Prove that sin inverse 12 by 13. Prove that sin inverse 12 upon 13 plus cos inverse 4 upon 5 plus tan inverse 63 upon 16 is equal to pi. This we need to prove. Now, we know the formulae where we can add sin inverse x plus sin inverse y, or cos inverse x plus cos inverse y, or tan inverse x plus tan inverse y. Means sin inverse can be added to sin inverse, cos inverse can be added to cos inverse. Sin inverse cannot be added to cos inverse. So for solving this thing, convert all the inverse trigonometric functions in sin and cos to tan inverse. कैसे करेंगे? See, sin inverse 12 upon 13. Sin inverse is perpendicular upon hypotenuse. So perpendicular 12, this is 13. Then what about the base? It is 5. So sin inverse 12 upon 13 is equal to tan inverse 12 upon 5. Similarly, cos inverse 4 upon 5. Cos क्या होता है? Base upon hypotenuse. So 4 upon 5. Then this is 3. So cos inverse 4 upon 5 is equal to tan inverse 3 by 4. So taking left hand side, sin inverse 12 upon 13 can be written as tan inverse 12 upon 5 plus cos inverse 4 upon 5 is tan inverse 3 upon 4 plus tan inverse 63 upon 16. Now this is tan inverse x plus tan inverse y. But in this case, if you notice, x into y multiply karo, 12 upon 5 into 3 upon 4. 12 upon 5 multiplied by 3 upon 4. 36 upon 20, which is greater than 1. So xy is greater than 1. So when xy is greater than 1, the formula is, if xy is greater than 1, then the formula is tan inverse x plus tan inverse y is equal to pi plus tan inverse x plus y upon 1 minus xy. So using this formula, this comes out to be pi plus tan inverse 12 upon 5 plus 3 upon 4 whole divided by 1 minus 12 upon 5 into 3 upon 4 plus tan inverse 63 upon 16. This is pi plus tan inverse 48 plus 15 upon 20 whole divided by 20 minus 36 upon 20. This denominator cancels with denominator, plus tan inverse 63 upon 16. This is 5 plus tan inverse minus 63 upon 16. 20 minus 30 is minus 16, plus tan inverse 63 upon 16. Now tan inverse minus x, we have a formula that says tan inverse minus x is minus tan inverse x. So using that, it is pi minus tan inverse 63 upon 16 plus tan inverse 63 upon 16. This cancels. So your answer is pi, which is your right hand side. Hence proved. Just check it out. देखो, अगर आपको तीन अलग अलग ट्रिग्नोमेट्रिक इनवर्स ट्रिग्नोमेट्रिक फंक्शन दे रखे हैं, एक साइन इनवर्स है, एक कॉस इनवर्स है, एक टैन इनवर्स है, तो इट इज ऑलवेज एडवाइजेबल कि सबको टैन इनवर्स में कन्वर्ट करो फिर सॉल्व करो. फाइन. नेक्स्ट, प्रूव दैट टू tan inverse half plus tan inverse 1 upon 7. 2 tan inverse half plus tan inverse 1 upon 7 is equal to tan inverse 31 upon 17. Tan inverse 31 upon 17. So 2 tan inverse half plus tan inverse 1. Left hand side lo. 2 tan inverse half plus tan inverse 1 upon 7. Now we have a formula 2 tan inverse x is equal to tan inverse 2x upon 1 minus x square. So using that 2 tan inverse x, this is tan inverse 2x, 2 into 1 by 2 upon 1 minus 1 by 2 the whole square, plus tan inverse 1 upon 7 as it is. So this is tan inverse 1 upon, this will be 1 by 4, 1 minus 1 by 4, 3 by 4, plus tan inverse 1 upon 7. This is tan inverse 4 upon 3 plus tan inverse 1 upon 7. Now जब भी tan inverse x plus tan inverse y करो, हमेशा एक बार x into y चेक कर लो. तो here 4 by 3 into 1 by 7, 4 upon 21 which is less than 1. अगर less than 1 है तो tan inverse x plus tan inverse y, formula is tan inverse x plus y upon 1 minus xy. So हमेशा एक बार चेक कर लो कि x into y less than 1 है या greater than 1 है. In this case it is less than 1 in both the cases. So tan inverse x plus tan inverse y is equal to tan inverse x plus y 4 by 3 plus 1 by 7 upon 1 minus 4 by 3 into 1 by 7. Take LCM and cancel the denominator simultaneously. What you will have is 4 7 are 28 plus 3 upon 7 3 are 21 minus 4. So this is tan inverse 31 upon 17, which is your right hand side. So another question that says prove that sine inverse 63 upon 65 sine inverse 63 upon 65 is equal to sine inverse 5 upon 13, sine inverse 5 by 13 plus cos inverse 3 upon 5, cos inverse 3 upon 5. Now right hand side lo, you have sine inverse 5 by 13 plus cos inverse 3 by 5. Now as I told you earlier कि साइन इनवर्स में ऐड होगा, कॉस इनवर्स में ऐड होगा. अब या तो इस साइन इनवर्स को कन्वर्ट करो कॉस इनवर्स में, या इस कॉस इनवर्स को कन्वर्ट करो साइन इनवर्स में, बट क्योंकि लेफ्ट हैंड पे साइन है तो इसको हम साइन इनवर्स में कन्वर्ट करेंगे। तो कॉस इनवर्स 3/5, कॉस क्या होता है, बेस अपॉन हाइपोटेन्यूज, 3 5, देन बाय पाइथागोरस this comes out to be 4. So cos inverse 3/5, cos inverse 3/5 is equal to sin inverse 4/5, perpendicular upon hypotenuse. Using that, this is sin inverse 5/13 plus sin inverse 4/5. Now we have a formula, sin inverse x plus sin inverse y is equal to sin inverse x under root 1 minus y square plus y under root 1 minus x square. So using that, this is sin inverse x, which is 5/13 under root 1 minus 16/25 plus 4/5 under root 1 minus 25/169. This is sin inverse 5/13 into, solve करो इसको, 25 minus 69, 9/25 का अंडर रूट 3/5 plus 4/5 into, now this is 169 minus 25, 144, 144 का अंडर रूट 12, 169 का 13. This is sin inverse 15 plus 48 upon 3 5s are 65. So it is sin inverse 63/65, which is your left hand side. Is that okay? Now another question that says prove that tan of pi/4 tan pi/4 plus half cos inverse a upon b, cos inverse a upon b plus tan of pi/4 minus half cos inverse a upon b is equal to 2b upon a, 2b upon a. So let half cos inverse a upon b is equal to a. This implies cos inverse a upon b is 2a, implies a upon b. Now left hand side, this gives you tan pi/4 plus a plus tan pi/4 minus a. हाफ cos इनवर्स a अपॉन b को a सब्स्टिट्यूट कर दिया. नाउ tan pi/4 प्लस a, tan 45 प्लस थीटा, फॉर्मूला क्या होता है, 1 प्लस tan a अपॉन 1 माइनस tan a प्लस इससे 1 प्लस tan a अपॉन 1 माइनस 1 माइनस tan a अपॉन 1 प्लस tan a. tan 45 माइनस a क्या हो गया, 1 माइनस tan a अपॉन 1 प्लस tan a. एलसीएम ले लो, 1 प्लस tan a द होल स्क्वायर प्लस 1 माइनस tan a द होल स्क्वायर अपॉन a माइनस b इंटू a प्लस b, a स्क्वायर माइनस b स्क्वायर, 1 माइनस tan स्क्वायर a. दिस इज 1 प्लस tan स्क्वायर a प्लस 2 tan a प्लस 1 प्लस tan square a minus 2 tan a upon 1 minus tan square a. This 2 tan a cancels, so it is 2 times 1 plus tan square a upon 1 minus tan square a, or it is 2 divided by 1 minus tan square a upon 1 plus tan square a. क्या किया, ये 1 प्लस tan स्क्वायर a को डिनोमिनेटर में लिखो, सो इट इज 2 अपॉन cos 2a. हाउ कम, बिकॉज 1 माइनस tan स्क्वायर अपॉन 1 प्लस tan स्क्वायर a, We have a formula that says cos 2a is 1 minus tan square a upon 1 plus tan square a. So we have used this formula 1 minus tan square upon 1 plus tan square a cos 2a. This is 2 divided by cos 2a is a upon b. b ऊपर चला गया 2b upon a. So which is your right hand side? Hence proved. Another question. Solve tan inverse x plus 1. Solve tan inverse x plus 1 upon x minus 1 plus tan inverse x minus 1 upon x minus 1 upon x is equal to tan inverse minus 7. Tan inverse minus 7. So लेफ्ट हैंड पे हम फॉर्मूला यूज करेंगे. सॉल्व मींस वी नीड टू फाइंड द वैल्यू ऑफ x. तो लेफ्ट हैंड पे हम क्या करेंगे? we'll use the formula tan inverse x plus tan inverse y. The formula is tan inverse x plus tan inverse y is x plus y upon 1 minus x into y is equal to tan inverse minus 7. So this is tan inverse x into x plus 1 plus x minus 1 the whole square divided by x minus 1 into x minus x plus 1 into x minus 1 is equal to tan inverse minus 7. Or this is take tan on both sides, tan of tan inverse. So you are left with x. So x square plus x square minus 2x plus 1 upon x square minus x square minus plus 1 is equal to minus 7. This cancels. 2x square minus x plus 1 is equal to minus 7x plus 7x minus 7. Or this is 2x square minus 8x plus 8 is equal to 0. X square minus 4x plus 4 is equal to 0. X minus 2 the whole square is equal to 0. X is equal to 2. Check it out. First of all, we have used tan inverse x plus tan inverse y. Tan inverse x plus y upon 1 minus xy. Take LCM and then take tan on both sides. Then solve the equation. You will get the value of x. Say, we'll go with another question. That says, solve for x. Solve tan inverse x minus 1, tan inverse x minus 1 plus tan inverse x plus tan inverse x plus 1 is equal to tan inverse 3x. Now you can see there are tan inverse involved. Take this tan inverse on the right hand side before solving. What you will get is tan inverse x minus 1 x plus 1. ठीक, fine. So this is tan inverse x minus 1 plus tan inverse x plus 1 is equal to tan inverse 3x minus tan inverse x. We can write like this. Take this tan inverse x on the right hand side. Now use the formula tan inverse x plus tan inverse y. This will give you tan inverse x plus y upon 1 minus x into y is equal to tan inverse x minus tan inverse y. That is tan inverse x minus y upon 1 plus x into y. This is tan inverse 2x upon 1 minus x square minus 1 is equal to tan inverse 2x upon 1 plus 3x square. Okay, take tan on both sides. So this is 2x upon 1 minus x square plus 1 is equal to 2x upon 1 plus 3x square. Or that will give you either 2x is equal to 0 or 2 minus x square is equal to 1 plus 3x square, or 1 is equal to 4x square, x square is equal to 1 upon 4, or this gives you x is equal to plus minus 1 upon 2. Now check it out. For x is equal to 0, the equation satisfies, and for x is equal to minus half, it may be. So you have three answers: x is equal to 0, or x is equal to half, or x is equal to minus half. So you have another question that says prove that cos inverse, if cos inverse x plus cos inverse y plus cos inverse z is equal to pi, then prove that x square plus y square plus z square, x square plus y square plus z square plus 2xyz plus 2xyz is equal to 1. Now to prove this thing, we are given with cos inverse x plus cos inverse y is equal to pi minus cos inverse z. We can write like this. Now cos pi minus cos inverse x is cos inverse minus x, so I can write cos inverse x plus cos on left hand side, cos inverse x plus cos inverse y. Formula is cos inverse xy minus under root 1 minus x square into under root 1 minus y square is equal to pi minus cos inverse z. So the formula is cos inverse minus z. Take cos on both sides. You will have xy minus under root 1 minus x square into under root 1 minus y square is equal to minus z. Take these square root terms on the right hand side and z on the left hand side. You will have xy plus z is equal to under root 1 minus x square into under root 1 minus y square. Squaring both sides, xy plus z, the whole square is 1 minus x square into 1 minus y square. You have x square y square plus 2xyz plus z square is equal to 1 minus x square minus y square plus x square y square. Now this x square y square cancels, and take these two x square y square on the left hand side, x square plus y square plus z square plus 2xyz is equal to 1, which is the required answer. So one last question. You will have tan inverse under root 1 plus x square plus under root 1 minus x square upon under root 1 plus x square minus under root 1 minus x square is equal to pi by 4 plus pi upon 4 plus half cos inverse x square. Now, if you look at the question, under root 1 plus x square and under root of 1 minus x square. So you have both the expression which is a square plus x square as well as a square minus x square. So you may get confused whether to substitute x is equal to sin theta or x is equal to tan theta. But in this kind of questions, we neither put x is equal to sin theta nor x is equal to tan theta. Instead, what we will do, we will consider this as a plus x upon a minus x the whole under root. Means we will substitute x square as cos theta. So put x square is equal to cos 2a. Put x square is equal to cos 2a. So left hand side becomes, this implies 2a is equal to cos inverse x square, implies a is equal to half of cos inverse x square. So left hand side becomes tan inverse under root 1 plus cos theta, cos 2a, under root 1 plus cos 2a plus under root 1 minus cos 2a upon under root 1 plus cos 2a minus under root 1 minus cos 2a. So this is tan inverse root 2 cos square a plus under root 2 sin square a upon under root 2 cos square a minus under root 2 sin square a. So this is tan inverse mod cos a plus mod sin a upon mod cos a minus mod sin. Now since interval is not given, तो जब इंटरवल नहीं गिवन हो तो हम ले लेते हैं फर्स्ट इंटरवल. फर्स्ट इंटरवल मतलब ऑल आर पॉजिटिव. तो इफ इंटरवल इज नॉट गिवन देन कंसीडर द इंटरवल एज फर्स्ट क्वाड्रेंट. फर्स्ट क्वाड्रेंट मींस all the trigonometric ratios are positive. So in that case it will be tan inverse cos a plus sin a upon cos a minus sin a. This is tan inverse 1 plus tan a upon 1 minus tan a, which is tan inverse tan pi by 4 plus a, which is pi by 4 plus a, which is pi by 4 plus half cos inverse x square, which is the value of a. So that's how it is solved. So one thing again, under root of cos square is mod cos a and under root of sin square is mod sin a. But when interval is not given, जब इंटरवल नहीं गिवन तो हम इन सबको फर्स्ट क्वाड्रेंट में कंसीडर करेंगे और सारे पॉजिटिव होंगे इन दैट क्वाड्रेंट. So divide numerator and denominator by cos a upon cos a 1, sin a upon cos a tan a 1 minus tan a, 1 plus tan a upon 1 minus tan a is tan pi by 4 plus a. Tan inverse tan x is equal to x. So here's the answer. So that are the few examples on inverse trigonometric functions. With this you may able to solve a whole lot of questions. So try the questions and ask the problems in the comment box. Thank you.